So, I'm looking forward to having a little bit of fun today with some ideas from science and some of the amazing leaps forward in human knowledge and understanding of the universe around us, and at the same time, along with that leap forward in our knowledge and understanding that the last few hundred years have brought us. Also an understanding that that all of our understandings of things are but frameworks, they're but models. So with our incredible leaps forward into the unknown has come, I think, a sense of humility about our position in the world and our ability to know. So if yesterday we spoke about the context of the present day, about how things seem to be falling apart in one sense, in another sense things have never been better, and there's some confusion on that. Where are we going and where are we right now? What I'm going to try to do over the next couple of days is present a cosmic context for understanding the present moment that could potentially also help orient us as we move forward into the next stage of the collective unfoldment of our consciousness. And I wanted to start, first of all, by, I suppose, my thesis statement, I guess, is more a question, and the question is, what if the erosion of dogmatic certainties and the subsequent decline of religious institutions following the scientific revolution and the Enlightenment, particularly acutely felt in the West, was actually a spiritual leap forward and not a regression into godlessness? What if what was eroded ultimately were building blocks that were not solid in the first place? What if what was being eroded were really institutions that had outlived their time, and frameworks of thought that had devolved into superstition? One thing that, and this will be an underlying theme of my remarks today, one, I think, very positive development that's emerged from this loss of certainty, from this death of the old, the death of God, as Nietzsche puts it, but really what I think he was talking about was the death of these outdated ways of thinking about the divine. I think one of the positive things to come out of it has been this recognition that so much of what we think of as certain is really not certain. The world as it presents itself to our senses can sometimes be a bit of a mirage. And this was one of the great thinkers of the Enlightenment, Immanuel Kant, was famous for his idea that the things in themselves are forever unknown to us, that everything we think we know is in fact mediated through the imperfect lens of our senses and the imperfect distortion field of our intellect and our preconceptions. And there's no way around that. That's, the world we're thrust into is a world in which we are forever separated as though by a veil from ultimate reality, whatever that is. Abdu'l-Baha says something similar in one of his talks in 1912. He says, the essential reality underlying any given phenomenon is unknown. Phenomenal or created things are known to us only by their attributes. The qualities appertaining to this organism, and he's speaking of a flower, are perceptible to us, but the intrinsic elementary reality or identity of it remains unknown. And just to sort of underline this state of uncertainty into which we find ourselves thrust, I wanted to say a few remarks about the intrinsic limitations of language, the limitations of words to properly capture reality. We assume, I think, without thinking much about it, that words neatly map onto certain elements of reality. An apple, a horse, a man. We can think of simple examples where it just seems clear to us that there's a one-to-one correspondence between a word and some element of reality. But so many of the words we use, particularly when we move into more abstract realms, it's unclear what is the reality that this word is attaching to. Is there actually a reality underneath the word that everyone is using as though it had some fixed reality underneath it? The philosopher of Buddhism, D.T. Suzuki, put this so well, I wanted to quote him here. He says, "We humans have the bad habit of giving a name to a certain object with a certain number of attributes, and we think this name exhausts the object thus designated, whereas the object itself has no idea of remaining within the limit prescribed by the name. The object lives, grows, expands, and often changes into something other than the one imprisoned within the name. We who have given the name to it imagine that the object thus named forever remains the same. Because for the practical purposes of life, or for the sake of what we call logic, it is convenient to retain the name, regardless of whatever changes have taken place and might take place in it. We become a slave to a system of nomenclature, of naming things, that we ourselves have invented." How true that is of religious concepts. These ideas like God and spirit and so forth that have such a long history, but that are kind of evolving beneath our feet as our consciousness expands and as our understanding expands. And maybe sometimes the word and the associations that we traditionally have with it don't keep up with the actual reality of what's going on. So yesterday I mentioned that one of the great destabilizing realizations of the scientific revolution is that the world is so much bigger and so much older, so much causally constructed and structured than our old sacred narratives can accommodate. And also I wanted to underline that the world as we now understand it to be is also far bigger than our language can accommodate, than our grammar can accommodate. For example, just to give a simple example, we have certain words to designate large things, big, huge, immense, enormous. There's a range of words that indicate things that are really big. But we have nothing in our language that remotely captures the immensity of the distance scales that we now understand we inhabit. The distance of, say, the Earth to the moon, just to take the nearest celestial object. How do you understand the incredible distance between here and the moon? In using the language, the everyday language that we've all evolved over thousands of years. We really are forced to use analogy, it seems. For example, if the distance from here, this summer school, to Helsinki was represented by the length of this gym from one end to the other. If we were somehow to shrink the world down so that to get to Helsinki it would just be a matter of going from one end to this room to the other, then what do you think the distance to the moon would be? it would be 1,300 lengths of this gymnasium. So we can kind of grasp maybe how far away the moon is. Okay, just walk from here to there 1,300 times, but that's like walking from here to Helsinki 1,300 times. But that's the easiest case, and that's just the beginning of, the vastness of our universe. Our ability even to use analogies to understand, the actual physical world as we now understand it, just breaks down very soon thereafter. If we were to try to understand using the same analogy, what's the distance from here to the sun? This is an object that's visible to us. It's a constant presence to us. Seems close to us in a way because we feel its heat and its light surrounds us. But in terms of the lengths from here of this room, how many room lengths would it be to the sun? 5.4 billion. What does even the word billion mean? How many of us can really intuitively grasp in our minds what a billion is? It's just a word with a different letter in front of it than a million. Some people probably even confuse million and billion because they're just two words indicating something really big. But really a billion is 1,000 times more than a million, which is 1,000 times more than 1,000. And that's just the distance from here to our sun. What about the distance to the nearest star? Just the nearest star in our own galactic neighborhood. We can't use kilometers or, we can no longer use words in our language. We have to invent new terms. So we invent this term called a light year. So, well, how big is a light year? A light year is the distance light travels in a year. Well, how fast does light travel? It travels at, how fast does light travel? It's 300 million kilometers per hour. 300 million, kilometers per second for an entire year. And how many seconds are in a year? I can't do the math in my head. I used to know that answer, but it's another few hundred million. So 300 million kilometers an hour, a second for as many seconds as are in a year. And that's just the nearest star to us. Well, we know already that the universe is, the distance to the nearest star is nothing compared to the distance scales of the universe. Then you have to talk about, the distance between us and the nearest star and the center of our galaxy. Well, that's another 50,000 or so light years. And then the distance from here to other galaxies, you can't use light years anymore because you're going to be talking about millions and billions of light years. So you invent another term. You call it a parsec, cosmologist, or a megaparsec. Well, how big is a megaparsec? 3.26 million light years. So already we're stacking on top of each other words that have lost their meaning to us. And likewise with the world of the very small. Our language is insufficient to capture, and I'm only talking about the tangible aspects of reality, ways that our language, our everyday language breaks down with the most tangible aspects of reality as we understand it. How small is an atom? Absolutely no way for our minds to conceive how small an atom is. If you just take a small handful of matter, any kind of matter, really, presumably carbon-based matter, a handful of dirt or something like that. That handful of matter probably has 10 to the 24 atoms in it. How big is 10 to the 24? It's a 1 followed by 24 zeros. And we stop being able to imagine this when we go to about 3 zeros. When we get to about 1,000, maybe we can kind of understand 1,000. You get beyond that, and we have 21 more zeros to go. Every time you add a zero, it's 10 times more than it was before. If you don't have some training in math, there's absolutely no way you can comprehend this. And even if you do have training in math, there's no way you can really intuitively understand these scales. So both the scale of the very large and the scale of the very small, our language fails us. So if our language fails us with regard to the most tangible and measurable aspects of our universe, how much more might it fail us when trying to describe the realms of the abstract. If words do so poorly with the physical world, what makes us think that they can do any better with the realm of that we call spiritual, abstract, intangible? And then let's just add to that problem if we're talking about how to communicate with people around the world and to get on the same level about concepts so that we can move forward coherently. What about the problem of different languages? It's not the case that every language, the words of every language map on a one-to-one basis to the words of every other language. So you have all kinds of ambiguities that arise from the imprecision of all the different languages that we use. So this is a problem because, well, how do we access reality on a day-to-day basis? We access reality, whether in our own heads or in our conversations with others, we access reality through words and through conceptual models built upon these words. And so I think one of the, immensely useful consequences of this explosion of knowledge in this age is this sense of humility, that we don't know. We may understand things in part, but we really don't understand the totality of things. We make educated guesses. We test those guesses, and through iteration, through repeating the testing of these guesses, we improve our guesses in the future. This is a pragmatic approach, and this is exactly the scientific approach to nature. You may guess where I'm going to go with this, which is, what if we apply the same humility, the same attitude of model building, the same attitude of the imprecision of language and words? What if we apply this to spiritual reality, to our understanding of religion, to our self-understanding of what the ultimate ground of reality is? We can guess that we would end up with a posture which is far more open to diversity, far more open to accepting different points of view, because we've let go of these dogmatic certainties of the past, and we realize to what extent we really don't know and we really don't understand, even when it comes to the physical world. So language then can be thought of then as this very limited vehicle for conveying meaning. And since the sacred texts of the religions, of all religions, are ultimately written down in the form of words, these sacred texts we can picture then as evolving models of reality, as evolving ways of engaging with a layer of reality that we presume is there, a ground that we presume is there beneath our feet, but which we never actually contact ourselves. Or if we do contact it, we don't know that we have. It's not like some red light starts flashing when we touch reality. It says, okay, this is reality. We might imagine we have, but we can never be sure. So this is then, I think, such a helpful realization from this systematic investigation of the world around us that takes the name of science, which is just practical wisdom being applied writ large, really. It's not magic. This understanding is that our theories, our scientific theories, our other theories, I'll call them theories, but our religious models are kind of like maps. Perhaps they describe pretty well a certain territory in a limited way, that words and language can. But that territory may extend into regions where the map no longer does very well. So this example of the world of the very large and the very small, it's kind of like our map, our everyday language, pretty neatly, nicely, and usefully covers the world of the everyday that we inhabit on scales of a few seconds to a few years, a few millimeters to a few kilometers. Our words, do a pretty good job. But you go outside of that, you get into like light years and megaparsecs, or the fantastically small distances of the atom, and our language really begins to fail down, to fail. It's almost as though reality is like three-dimensional and our maps are two-dimensional. It's almost like, well, reality is a sphere, like the surface of the Earth. Every map that we have, every two-dimensional map, nicely covers some part of that. You could really nicely capture the outlines of a country, for example, or even a continent on a two-dimensional map. But if you want to extend that map out to include the entire sphere, you can't do it without stretching or tearing or poking some hole in the reality of the thing. There's no way to faithfully represent the surface of a three-dimensional object in two dimensions. In a way, our language is similar. You know, human language breaks down at certain points. It gets stretched, it gets torn, and at points it breaks down entirely. That doesn't mean, of course, that we don't use words or we abandon words and try to find something else. We're stuck with words. This is what we have. But being aware of the limits of any conceptual map of any territory helps keep us humble, helps keep us aware that there may be others who are off our maps. They're working from a different map, and maybe that map that they're working from is a very nice and reasonable approximation of the territory that they're living in, the intellectual, spiritual territory that they're living in. And maybe there's a meta map out there that allows you to stitch together these various maps and show that actually there's no conflict between them. You'd have to do a lot of work at the borders of the maps to show that, you know, they align somehow at the borders. But if you go to the center of either map, you're going to find you're off the other map. This is exactly, I think, what Shoghi Effendi says about the Baha'i writings. People would write to Shoghi Effendi and say, I see all these contradictions. It says it this way here, and it says the opposite here. And Shoghi Effendi said, the writings are like a sphere. He said there are points on opposite poles, but in between are the thoughts and ideas, the meridian lines that connect it all, that join together these disparate maps into a single map. Another great, and I think a very closely related great insight that we have from our scientific exploration of the world is that sometimes a map can do amazingly well, incredibly accurate in predicting a certain set of phenomena. But if you want to go beyond that map and explain phenomena beyond, you need to switch to a different theory. And that theory may be based on completely different philosophical foundations than your original theory. Even though the difference, the measurable difference from them, might be microscopic. So the example I'm thinking of, which everyone will at least be familiar with at some level, is our theory of gravity. And as we know, Isaac Newton was the first to write down in mathematical form a theory of gravity, which was extremely simple, extremely powerful, was able to, with this theory, which is, you can write down with a single phrase, GMM over R squared, it's the, and there's a minus sign in front of it for the physicists among us, which just says how powerful the force is, the attraction is between two bodies of two different masses. And it's related to the inverse square of their distance. And with that little map of reality, you can do incredible things. The first things people did perhaps was design some sort of weapons of war, catapults, things like that. Of course, that's the first thing you do when you get this kind of information. If you're a human being on this planet, you use that for very practical, pragmatic purposes of taking over, say, some other country or territory. But when you extend that information to the cosmos, you can start explaining things that before were just taken as givens and which really were not understood at all, like the orbits of the planets. Why is it that the planet's orbits orbit in exactly the shape that they do, which is not quite circular. It's a little bit off from circular, a teensy bit off from circular. It's called an ellipse, which is like a little bit of an oval. But still, if you were, you have to kind of squint to see that it's not exactly circular in the case of most of the planet's orbits. I'm talking about Newton's laws. And the application of Newton's laws shows us that actually the orbits of planets are elliptical. And this is the case for all the planets, even the inner planets like Mercury and Venus. And Mercury is a very special case because Mercury, like all the other planets, has a mostly circular orbit, but it is slightly elliptical, which means it has an axis, a long axis, and a short axis. And if you use Newton's laws, then you end up with a very stable orbit, which is just constantly going around in that elliptical orbit forever. But if you observe closely what's happening with the orbit of Mercury, you find that it's not just a static ellipse that stays at the same angle, but the long axis itself is rotating slightly, ever so slightly. How much it's rotating is just incredibly small. It's another word that, well, what does this word mean? It's a few arc seconds per year. So every year, it's not even a degree. It's a tiny fraction of a degree of a circle that it rotates per year. But our ability to measure these tiny differences, came along with the scientific revolution and the invention of telescopes and ever more powerful means of observation. So we know that this is the case. Which seems like, okay, maybe we just aren't measuring it right, or we're missing, there's some other object that's perturbing its orbit. It turns out that the answer, and this is called the precession of the perihelion of Mercury, that's the technical term for what I'm talking about. It turns out the only way, well, I won't say the only way, I'll say one way to explain the precession of the perihelion of Mercury is discarding Newton's laws, or if not discarding them, setting them aside and contextualizing them as a special case of a very simple cosmos in which masses tend to be small and the timescales tend to be small. But as the masses get bigger in relation to each other, this other effect comes in. And it took an Einstein in the last century to figure out what was happening. And what was happening was, and this is like, you throw out words, and what do these words mean? Einstein's theory was that masses as they move against the background of space and time, don't move against just this fixed Cartesian coordinate system, but rather that grid of X and Y and Z values, the Cartesian grid that we imagined using Newton's laws was the substrate against which everything moved, is itself a kind of fabric. I'll say the word fabric, it's not a fabric. It stretches, it doesn't really stretch, but let's use the word. It kind of stretches as though you were dropping a heavy weight on a pillow, on a bed sheet. So it creates a little dimple, and that dimple represents the perturbation of space and time, which is created by this mass. It turns out if you use that theory, Einstein's theory of general relativity is what it's called, then you can explain the precession of the perihelion of Mercury. Exactly, it works out perfectly, at least within the limits of our current observations. Now, why did I take so long to describe this? Because the difference between Newton's laws and Einstein's laws, in terms of what they predict, is microscopically small. It's so small you can almost count it as an error in your measurements. But the difference philosophically couldn't be greater. There is a tiny difference in the, and this is the precession of the perihelion of Mercury. And this is a comment that the famous American physicist Richard Feynman said about this sort of phenomenon. He says, finally and most interestingly, philosophically, we are completely wrong with the approximate law in this case being Newton's laws, Newton's law of gravity. He says, our entire picture of the world has to be altered, even though the mass changes only by a little bit. This is a very peculiar thing about the philosophy or the ideas behind the laws. Even a very small effect sometimes requires profound changes in our ideas. So, one more reason to be humble about the maps that we make. The maps that we can make, our conceptual framework, and I'm talking not just our scientific conception of things, but our religious conception of things, may work really well for our local area of the universe, for our personal interactions, for our communities, for our religious group. But the fact that it works really well, it seems to get us where we need to go, doesn't mean that there aren't other maps that have completely different philosophical presuppositions that might work just a little bit better. And if they work just a little bit better in our region of space, they might work profoundly better at the edges. So, another way to think about the maps that we use is very pragmatically. You know, the object of most maps is a practical object. It's to help us navigate something. You know, maps of the ocean and getting ships from point A to point B led to the creation of the Mercator projection, which was easier for ships to navigate because of the way the meridian lines were drawn on the map. Even though the Mercator projection, as we all know, creates huge distortions towards the North and South Pole. And of course, the North and South Pole itself just gets completely blown up on the Mercator projection. So it's useful for certain purposes, but it's really inaccurate when we ask it to do other things. A subway map is a similar kind of a thing. It's really, really useful to get from point A to point B in a large city, to refer to a subway map. But if you were to take that subway map and say, well, how good of a representation of the actual city is the subway map? You may be surprised just how much distortion goes into the creation of a subway map. I used to have a little GIF image that showed just how distorted it is. Someone has taken this map of the London Underground and compared it to the actual map of the city, and you can sort of visualize just how much is distorted. The distances get pulled together. Even the relative positions, the north-south or east-west positions of subway stations will be swapped for the sake of getting all the information on the map, because it's not important for you to know which subway station is farther east or farther north than some other subway station. Not for the purposes of this map. The important thing to know is, how do I get there fastest? And taking the least amount of time standing in front of the map and figuring out where to go next. In a way, religions are like subway maps. You know, they get us from point A to point B. They navigate the world of human relationships. They navigate this world, the interior world, through which we hopefully are on a journey of spiritual progress towards the transcendent, and they tell us these are the subway stations, this is how to get there, these are the times to get on it and get off, and so forth. But to assume that this framework of religious ideas and conceptions and practices is an accurate mapping onto the underlying reality of things is perhaps a bridge too far. Yeah. We would like to assume, of course, that it correlates, and of course, this map of the London Underground does correlate to the underlying map of the city. I mean, it's not completely scrambled, but there are a lot of distortions that have to be made in order to create that map. And similarly, I think what the summary of everything I've said up until now is humility. It's understanding that so much of what we do as human beings is approximative, pragmatic, model building, map making, And up until the scientific revolution, the Enlightenment, people tended to view with a very kind of absolute lens their own particular map that they were navigating with. And so a necessary prerequisite of moving human civilization into a different frame of reference in which different peoples, different cultures, people of different religious backgrounds, sometimes with profoundly different ideas about the nature of these spiritual concepts. I'm speaking particularly of our concepts of God, which vary so widely from culture to culture. I'm suggesting that these are not so much a matter of there's a single truth out there somewhere and then the rest are all in error. And our project is to somehow convince everyone else that this particular way of thinking about it is the correct way. But rather, to understand these other ways of navigating our spiritual existence as different regions of maps that usefully, over the course of history, have plotted out these different regions of a very complicated surface, and that complicated surface is the surface of the human psyche, the surface of human beings and human cultures and civilizations. Another aspect of this map analogy is that a map is not a static thing because the underlying territory changes. And this is the point that D.T. Suzuki makes with regard to words. This is the underlying realities change. This is a map of Jerusalem, which was found on the floor of a church in Jordan, and it dates to around the 6th century AD. So well after the destruction of the Second Temple, of the Jewish people, and well into the era of the dominance of the Greek dominance of the city. And so a lot of the old structures that we know from the Bible were not there. Other structures are present. So where do you find the Dome of the Rock? Well, it's not really there, but here you see the Cardo, this long street, east-west street, only parts of which are now visible to the modern visitor to Jerusalem. You see this big structure here is the Church of the Holy Sepulchre, given great prominence because it's the Christian church. So of course they're going to make the central sort of icon of Christianity, that's going to be the largest thing in the city. And off to the west is the Damascus Gate and so forth. But the idea, the thought here is that no one would want to use this to navigate the modern city of Jerusalem. You couldn't get anywhere with this map. But that doesn't mean the map wasn't perhaps a useful representation of the city back in 6th century AD. It also doesn't mean the map is not still of value to us today as a work of art, as telling us something about the past that we want to know about because we're always curious to know. So the fact that these maps get out of date invalidates them as means of getting from point A to point B, perhaps in the modern world, but they don't lose their entire significance and usefulness to us. And you can connect the dots there with, we can also talk about religions in the same way, as maps that get out of date and need to be updated. So, jumping from this idea of the limitations of language and the relative validity of the maps we make about the world, I wanted to briefly, and I hate even doing this because each of these ideas needs a week to really explore the way it needs to be explored, because it's just fantastically interesting and complicated in one way, simple in another way, pillars of the edifice of modern physics, of how we people who study physics and try to formulate its laws most simply and most completely have come up with these concepts as among our best maps of the terrain, so to speak. And the reason I'm going to introduce these, you'll see, and you might even guess as I'm introducing them, very, very briefly, with doing no justification to the beauty of any of it. One of the first pillars of modern physics is the idea of relativity. Of course, associated with the name of Einstein, and connected to really two kinds of relativity. There's the relativity of how we measure space and time and mass and energy as a function of our velocity with respect to another reference frame. It's kind of a complicated way of saying what you measure physically depends on how fast you're going. It depends on something specific about your state will determine how you measure things around you. And two people in different states, you say moving in different velocities relative to each other, will measure the same phenomenon quite differently. But that's not a contradiction, because you can understand how it is that they get to those different conclusions by understanding the structure of this law of relativity. It extends also to the relativity of the space-time framework itself through the general theory of relativity, that it's almost like a kind of a warped fabric. So there's an image here of a planet sort of in this warped space-time, which is a very poor signifier of the theory itself. Because there really is no good image or word in our language that can really capture this, the true beauty of this idea, which has to be expressed in mathematical language. Another pillar of the edifice of modern physics is symmetry and invariance. And again, well, what is symmetry? Everyone understands intuitively the idea of symmetry in objects like a butterfly or a snowflake, things that you can rotate a certain number of degrees and you get the same thing. Joe knows all about this, making beautiful symmetric images for the pleasure of people around the world with nine-sided symmetries. And invariance is sort of the flip side of symmetry, that that certain things stay the same and certain things can be changed. And here's where also the snowflake is like such a bad representation of this idea, because it captures one very simple aspect of what are called discrete symmetries. You rotate things a certain amount, you flip them on an axis and you get the same thing. But the real symmetries used in theoretical physics are what are called continuous symmetries. If you move something just by some small incremental amount, something stays the same. And that tells you something very profound about the structure of reality. And I'm not going to go any further into it than that, but I'll leave it there, because we have one more to do, which is complementarity. And again, the image is horrible, but there's absolutely no image that captures the idea of complementarity. Complementarity being perhaps most well known to us in the quantum mechanical context of the idea that particles and waves are in some way complementary ways of describing the world at the smallest scales. The smallest particles of matter, the electrons, atoms, even smaller still, quarks. These small particles, which we can throw out names for, but what are they really? They all, depending on how you set up your measurement, they may either appear to you as particles or waves. And it seems like there's no way that something could be a particle and a wave at the same time. But somehow, and it's true that they can't be, but how you look at it determines what it's ultimately going to be. So you might maybe you'll guess where I'm going with this, that these sort of pillars of the edifice of modern physics are, in the words of Frank Wilczek, who was one of the architects of the standard model of particle physics. He says these big ideas, relativity, symmetry, invariance, complementarity, form the heart of modern physics, both on the side of gravity and on the side of quantum mechanics, which haven't yet been brought together yet. He said they should be, though they are not yet, central to modern philosophy and religion. I thought this was such an amazing insight, coming from someone who's not a religious person himself, but he intuits already that there's something profound going on here that might be useful to people thinking about religious ideas. And what are those religious ideas? Well, relativity, we should already be familiar with that. The relativity of religious truth is one of the core principles of the Baha'i faith. What we deem to be most true and certain and correct is a function of time and place. And it's important that we include time and place, because the relativity of religious truth is a truth that religious systems and conceptions evolve over the centuries and millennia in time, but they also differ at any given snapshot in time. They differ from place to place. So they're, at this moment in time on the planet, we're not talking about the evolution of religion, there are these different religious groups with different conceptions of the divine, all living spiritual lives, all with ideas of virtue, ideas of how to treat your neighbor, ideas of how to live as a fully realized human being in the world, which are surprisingly similar to each other. And if the undergirding theologies of it seem to be complementary, like one is a particle and one is a wave, maybe we can understand this relativity of religious truth in light of complementarity. That, you can't sort of hold in your head at the same time this robust monotheism of the Western religions, like Judaism, Christianity, and Islam. At the same time as you hold in your head the non-theistic religiosity of, say, a Buddhist or a Taoist. It doesn't even have a positive conception of God. It would never enter into their heads to try to prove logically God's existence, for example. But the spiritual orientations that come out of these great religious traditions of the East and the West are so remarkably aligned with each other. Maybe this is an example of complementarity in religious thought. It's not a matter of one being right and one being wrong. It's a matter of there being relative perspectives or complementary perspectives. So that, just to suggest, as I have been throughout this presentation, not only that the fruits of the Enlightenment in this immensely expanded understanding of the world around us have not only given us a sense of humility about our own limits, the limitations of our language, the limitations of our conceptual frameworks, but the content of the discoveries are remarkably aligned with the spiritual principles that, as Baha'is, we believe are undergirding and underlining truths which are the foundations of all the faith traditions on the planet. But I don't want to suggest that the story ends there and that they've just figured it out. Science has just figured everything out, and there's no need then for anything beyond that, because there's something incomplete, as we all know. Looking at the universe as beautiful as it is, and as particles and the void, even if these particles are sometimes waves, depending on if you're looking at them or not, this view of this vast emptiness populated by this wisp of matter, which is, in certain places coalescing into stars and planets, and in other places dispersing into the emptiness of the cosmos. This idea that maybe on a few of these planets, accidentally, as it were, life may emerge, and maybe on even a smaller number of those planets, intelligent, self-conscious life may emerge and start asking these uncomfortable questions about the purpose and origin of it all. The scientific view can never get beyond the best it can do is say that our existence, the existence of consciousness, the existence of meaning and purpose, which pervades everything we look at, the best science can do is say that is a very happy accident. It's a happy accident, obviously, because we're here to enjoy it, and it's made possible by the fact that the universe is really big, and it's very old, and there's a lot of matter in it. And if you give it enough time, something like this is bound to happen, I suppose. So you make it big enough universe, and something as improbable as we are will eventually emerge. That's really the best that you can do, even from the perspective of these amazingly beautiful and powerful theories like relativity, symmetry, and variance. Because the best that the current scientific picture of the world can do in terms of giving us a broad picture of where things are going is disorder. That's really the best we've got. That's the story of the universe at the largest scales, is entropy. The technical term for it is entropy. It rules the day on the macro scale. That is like the one absolute, fundamental, rock bottom, your physicist, your average physicist who's studied, all the way through and learned the forces of gravity and electromagnetism and the strong and weak nuclear forces and so forth would say, the only thing I'm really sure about is entropy. Gravity, that theory may change. Electromagnetism, maybe we're going to find a better way of doing it, but entropy, that's our rock bottom truth. There are different ways to formulate what the theory of entropy is, and again, here's a very impoverished attempt at visualizing what it is, but I suppose it captures a little bit intuitively what we're talking about. Disorder is more likely than order. And as time goes on, it's much more likely that a system is going to move into a disordered state than that it will move spontaneously into an ordered state. Because there are just so many more ways that things can be disordered. That's sort of, in a nutshell, what the theory of entropy is. It's almost as though the universe is like a machine that's running down. It's running out of gas, and there's no way to put gas back in the tank. Another way to put it is that heat always flows from a hot body to a cold body. Which also means that eventually in the universe, everything is going to eventually reach the same temperature. Thermodynamic equilibrium. All the stars, which are currently these hot bodies, radiating energy and heat, are eventually going to go dark. And all of the energy and heat that they contain is going to be spread evenly throughout the universe. So this is the best that the scientific picture can give us. A picture of the ultimate heat death of the universe, in which all the lights finally go out, one by one. And not in scope in this theory, not covered by this theory, are everything that you see around you when you go on a walk in the woods. Everything you see around you is moving in the opposite direction than entropy. All the living things are progressing, they're growing, they're adding more complexity. They are producing seeds and fruits to create the next generation of plants that will embody even a higher degree of complexity. Likewise with all the animals around us, all our environment, of course, at the same time that we see and our senses are filled with counter evidence to entropy. We see life in progress everywhere. We also see the destruction and disintegration. We see the entropy as well. We see dead things. We see things returning to the dust. But we know intuitively that life and death and composition and decomposition, the twin forces of the cosmos, of civilization, are both necessary. That you need one to have the other. You can't have a universe that only has integration or only has disintegration. Of course, if you ask a modern physicist, they would say, no, it's just entropy. This imagination that there's some spiritual force that tends towards evolution, that tends towards the upbuilding of matter, that tends towards the emergence of consciousness, what some call spirit. They say, no, that's just imagination. The universe is big enough and old enough that entropy can be the entire explanation of everything. And there's enough energy moving around at this stage in the life of the universe, particularly from our sun, which is pouring out entropy, low entropy energy, that is, and it's pouring upon the surface of the earth. And this temporary state of affairs, of heat moving from one place to the other, is allowing life to happen. It's almost like this chaotic bubble of temporary complexity in a larger universe in which everything is ultimately running down. So the physicalist, the scientist would say that yes, we don't understand how life emerged. We don't understand all these details, but we can kind of push it into this black box. And the black box is time and the infinite size of the universe and energy flows and the fact that energy flows permit temporarily complex things to exist. So you can perhaps guess at where I'm going with this, and that is that for Baha'is, of course, and by Baha'is I don't mean just members of the Baha'i faith, I mean Baha'is in the sense that Abdu'l-Baha says, people who understand that there's a spiritual dimension to existence and are trying to live that. He says all of those people are Baha'is. He's redefining the word for us. Those who are oriented towards life and who recognize that life and meaning are a thing, and they're not just an accidental thing, but they're the actual point of the thing, naturally would take issue with this empty picture of the universe. But they wouldn't take issue with it by saying, oh, the scientific picture is wrong. They would say, well, the scientific picture is probably incomplete. It's as though this process of integration and disintegration, which is the circle of existence, it's arcs of ascent and descent, we're going to get more into this tomorrow, are the complete picture. The cosmic picture is that everything is being born and growing and reaching its limit, and then it's getting old and dying. And there is a constant circle, really, a process of integration and disintegration. And the last few hundreds of years of scientific progress have brilliantly explained for us and uncovered the contours of this side of disintegration. They've shown the law of entropy, rock solid, all of these laws that work on the micro scale, the laws of electromagnetics and nuclear forces and so forth. But those who see life and meaning as being more than just accidental would argue that there may be something other than entropy acting at a macro scale. What is this other thing? And this is where words fail, because, what's the reality attaching to these words? So I could throw out a word for you. Spirit. What does that mean? And everyone has a different idea of what spirit is. Abdu'l-Baha talks about it a lot. We'll be getting into this more tomorrow. If there is a counter process to the force of entropy that tends towards the upbuilding of matter, this force has to act within the constraints of what our current physical picture of the universe already tells us. In other words, we're not looking for some invisible fifth force that physically pushes atoms together, that We don't have a name for it yet, but at some point we'll measure it, and this represents the activity of what was previously thought of as this invisible spiritual dimension of the physical world. I don't think that's where this is going. I think it's going to go more in the direction of entropy itself. Entropy is not a force that you measure at a microscopic scale, but it is an emergent property. When you get enough matter together and you look at what happens over time, you find that because disorder there's more ways to be disorderly than there are to be orderly. That's where the law of entropy appears. It sort of appears in the actions of things at a large scale. Could it be that similarly, there's another thing, complementary to entropy, that acts at large scales, that tends towards the upbuilding of things, increasing complexity of things, and ultimately the emergence of consciousness. What I'm suggesting is something that, and this is a controversial book, but I think he makes some good points. This is Thomas Nagel, who writes fairly recently a book called Mind and Cosmos, where he also examines this physical picture of the world that doesn't seem to make explicit space for life and meaning and consciousness. And he asks, as a non-scientist, which is why it's kind of controversial, isn't something missing here? Could there be space for what he would call a teleological principle? That is, a principle that that tends towards the upbuilding of things as opposed to the breaking down of things. And he puts it this way. He says the teleological hypothesis is that value may be determined not merely by value-free chemistry and physics, but also by something else, namely a cosmic predisposition to the formation of life, consciousness, and the value that is inseparable from them. Some form of natural teleology would be an alternative to a miracle, either in the sense of a wildly improbable fluke or in the sense of a divine intervention in the natural order. The tendency for life to form may be a basic feature of the natural order, not explained by the non-teleological laws of physics and chemistry. And perhaps this as yet undiscovered thing will at some future point be discovered by science. That should be an open question at this point. Perhaps it will remain forever undiscovered because it can't be expressed in mathematical terms, and it can't be measured through means that are available to us. And I think that I'll suggest that what's going on here is similar to what Abdu'l-Baha has said in many places in his talks in the West. I think he's landing on the same idea, and he's using his own special terminology. But he frequently has said that, and this is in one place, he says those informed with divine philosophy answer, and they're answering this question of how can we be here, how can beings like us exist in the world, that there are three theories of composition. First, accidental composition. Second, involuntary composition. And third, voluntary composition. So if you've read talks by Abdu'l-Baha, you may be familiar with this. And by accidental composition, he's talking basically about randomness. What modern physicists, biologists would say, this is how life appears. Large amounts of matter, large time scales, eventually DNA, RNA just kind of spontaneously forms in some warm pond, I think is how Darwin put it. And no one has really done better than Darwin's first guess when he introduces the theory of evolution and human origins. He imagined it just took place in some warm pond somewhere. So that's this accidental composition. And Abdu'l-Baha says, he invalidates each one. He says, well, it couldn't be this because of this reason. It couldn't be this because of that reason. But first of all, he says accidental composition is one possibility. He says the other possibility is involuntary composition, also necessary composition. That is, things just have to come about this way. And this corresponds to, so if the first corresponds to entropy, the second would correspond to the laws of physics as we know them, the set laws that say if A then B, law of gravity. the laws of electromagnetism, nuclear forces. And he says that's not capable of bringing life into being either. Which leaves, Abdu'l-Baha says, a third possibility, which he calls voluntary composition. And I think voluntary composition, which he says is the composition by some greater will, some greater power. And he's using language that can easily slip into an interventionist picture, that there's some external spiritual force and it's moving things around. But I think a deeper take on what Abdu'l-Baha is saying is he's suggesting that alongside of the physical processes of what Abdu'l-Baha would call the arc of descent, and we'll talk about that more tomorrow, there's a complementary process, an ascending arc, something that tends towards composition. And we can call that a will, because language is a model. In one model of language, we can say, oh, that's God, and God has an intention for us. God wants to be loved. God creates us so that we can love God. That's one map. That's one sort of map of a territory, which has been a useful map for thousands of years. There's another way to map that same thing, in which the divine is not a being, is not a personal entity, is not a provable, rational thing, but is something more like the ground of being. It's something more like the thing towards which everything trends, which itself is not a being like us, because we have a tendency to anthropomorphize when we think about these sorts of ideas. But we're going to talk, if this session was more about the arc of descent, and the sort of half of the circle that modern science has gotten right, and very accurately. Tomorrow we're going to talk about the arc of ascent. We're going to talk about that mysterious process which leads to the upbuilding of things, which leads to the evolution of things, the physical evolution of things on this planet, as well as the cultural and spiritual evolution of human beings as societies. So, just to recap, because I dealt with a number of topics. Question is, over the last few centuries, has it been a step backwards or a step forwards? It might seem like it's been a step backwards because we're turning away from God, the churches are emptying out. I'm arguing that it's been a massive step forwards. It's a step forwards because now we understand better than ever before that reality can only be approximated. The certainties of the past, we had to let go of those certainties in the past to get forward into the next age of human consciousness. And among those certainties is the idea of language somehow representing absolutely the realities of things. It may not carve nature at its joints. There may not be a one-to-one correspondence between words and realities. Our models, our scientific models, produce successively more useful approximations, but we never know that we're actually touching reality. These approximations can be super accurate, even though the underlying assumptions can be totally wrong. Just like Newton's laws, super accurate in the domain, but we know that Einstein's theory is more complete and better describes a much broader range of phenomena. And the philosophical underpinnings of Einstein's theory are completely different, even if in a certain region the results are indistinguishable. Very important insight, I think, for our spiritual understandings as well. That maps are useful approximations, but which can also become outdated and be distorted in places. And that relativity, complementarity, symmetry, invariance, these are deep structures that make multiple models of observation inevitable. All of this, I think, are grist for the mill. Important fundamental insights about the world around us, which have not yet been applied to the spiritual domain, but which we will see the Baha'i writings almost point for point echo. And as we'll talk about tomorrow, we'll talk about this complement to entropy, which is the dominant large-scale emergent process in the physical world.